Hello everybody, welcome back at the Vitrolife Group Academy studio. I'm here at ASRM in New Orleans. I would like to present our next speaker, that's Dr. Hamish Hamilton, and he's going to tell us about the use of antioxidants in their program. Thank you.
Thank you very much, Jakob. Thanks for having me here today. I'm presenting work today on, the title is A Radical Approach to Stress Reduction in Culture, riding the antioxidant wave. And this is really a story about the implementation of a single-step culture media made by Vitrolife with a formulation of antioxidants in there to protect the culture system. Now this is work that was led and done by our Queensland Monash IVF team and implemented on our laboratory on the Gold Coast. So I'm here at ASRM, so Dr. Dan Morgan and Kate Watson are the people who've done this work, and so I would like to acknowledge them in that. So today I'm just going to talk about, we acknowledge that embryo culture is stressful for embryos and can be stressful for embryologists as well. And really our job is to really reduce that stress. So we're going to talk about that. I'm going to talk about why we made the change to single-step culture media, and also transition from sequential to single-step, how we did that, because it's not just about coming the next day and starting single-step. It has to be well planned and a lot of consultation, staff engagement, training, and then the post-implementation monitoring of it. So embryo culture is stressful. We're holding and culturing embryos in a laboratory which has light, free radicals. These things don't normally happen in utero, so we really have to be very proactive about how we minimize that. And so it's our job to ensure that the system is set up for that minimal stress in the system. And our embryologists are manually handling the embryos, moving them from one culture dish to another for embryo transfer, for egg collection. So it's a very stressful job in itself, but we have to minimize that. And so this is a very important part of why we've introduced this culture media. So what we try to do is we minimize exposure to oxygen, and you all know this, through a low oxygen culture environment. And what we wanted to do with this project was transition from two-step culture media into a single-step culture media to reduce the handling on the embryos. And we think that this was the right time to do it. Single-step has been around for a long time, but we now have the embryo scope, which is a time-lapse incubator, and where you can actually culture them for long periods of time with looking them without having to take them out of the incubator. And I think the formulation of single-step culture media has advanced a lot in recent years, and it was now at the stage where we felt it was time clinically to introduce that. So what we tried to do and the main reason is we want to introduce systems whereby the embryologists are not distracted or don't have as many tasks in the embryo lab, and they can focus on other things and leave the embryos to be uninterrupted. So why did we change? As I said, the culture systems have improved quite a lot in recent years, and that's really important. Confidence in maintaining the environment is a lot higher. Less interruption to culture. Every time you take the dish out of the incubator, you're changing the temperature, you're changing the pH, and you're exposing the embryos to oxygen. There's less handling, so less risk of an error or an event. Less transfer, so less possibilities of it's less complex, and traceability becomes important. And it's a continuous improvement step that we made. And it wasn't the first time we'd used time-lapse single-step before. We had published this on a patient that didn't have a zona pellucida, and we advanced that for the single-step because we wanted to have minimal disruption to the embryo, and we got a pregnancy from that particular patient. Transitioning from sequential media to single-step media. We continuous culture systems using two-step and single-step containing antioxidants went really well. The implemented GTL following more recently by the actual antioxidant GX media suite at our lab in the Gold Coast. And we had to engage everyone in that process, doctors, scientists, patients, and we had to proactively educate them and change the system gradually. And that was really important. So we had to change our laboratory work systems, because we had different timings of embryo steps, moving the embryos from dish to dish and refreshing. One thing I will say is that we still, in this process, maintained a day 4 refresh in this particular data, because we were doing assisted hatching on day 4, so we still kept a day 4 refresh, but we're going to phase that out in the future accordingly. We had to educate our scientists, we had to educate our doctors. We developed frequently asked questions for patients. Obviously, we ensured we had all the supplies so that we could do the transition really well. And all the data went to our group scientific advisory committee for review. And we've now moved on to implementing it into other labs. So, and then finally, we keep reviewing, and we still do today, the transition and the results that we're getting from it. So here's an example of our patient frequently asked questions. Why have we moved to single step? We're using single step as our preferred media. It's beneficial to the embryos. Are there any additional risks? And will this cost more? So we really wanted to involve our patients in that process and make sure they're brought on that journey as well, because previously they would have been in a two-step culture system, and having a different system may have caused alarm. And when we did this transition, we were doing it in parallel with the two-step and the single-step. So it was very important that we established a very good schedule that was tight, and this is an example of that schedule. So this is the actual suite that we used, and you can see at the top there we've got day 0 at the day of egg collection, day 1, day 2, 3, all the way through to day 6. So in culture we used the Vitrolife culture system, which includes GX IVF, GX MOPS, and GXTL on the day of egg collection. And then obviously they're transferred into GXTL from that point on. The fertilisation was checked, and as I said before, on day 4 we refreshed that to a new fresh dish of GXTL, and that was, as I said, because of assisted hatching. On day 5 they were assessed for embryo development, for transfer freezing and biopsy, and transfer is always done in embryo glue. And biopsy is performed in GXTL because we have a CO2 controlled environment to be able to perform that. And this is the current results that we've got from very early stages. And as you can see, we wanted to make sure we're first of all doing no harm and that the transition is successful. And this is for a graph showing KPIs for autologous stimulated cycles. So we've got you can see the blue column is two-step, the orange column is GTL, and the grey column is GXTL. And so we've got average age, which was equivalent to all media. The fertilisation results were strong in all of them, a little bit higher in GXTL, but there's no statistical significance in these. This is just to monitor to make sure that we're transitioning well. The utilisation was at least equivalent, if not better. Clinical pregnancy was not statistically different, a tiny bit lower, and the preclinical pregnancies were not statistically significant either. But what was important that we do a lot of freeze-alls in our lab, and a large proportion of our patients in that lab have all the embryos frozen. And so it was important for us to also monitor the frozen embryo transfer results afterwards. So this is the graph showing the frozen embryo transfer results with GXTL. So again, in blue, two-step media, orange GTL, and grey GXTL. And as you can see, the results were at least equivalent for average age, survival, clinical pregnancy, and preclinical pregnancy. So on the whole, it was a very successful transition, and it's something we're now starting to, having done that successfully in our Queensland laboratory, we've started to introduce it into our other laboratories around Australia. And so we continue to monitor that, and we'll look forward to giving you another update. And I'd like to acknowledge Dan, Morgan, and Kate Watson for the work they did with this. Thank you. Thanks.
That's great. Thank you very much, Hamish. One question I've got for you is, you mentioned about the frequently asked questions that you created for patients. What was the response from your patients when they got to know that you are going to switch media? How did they absorb that information?
Yeah, I think our patients were very reassured by particularly the less interaction with the embryos and keeping them, in the embryoscope. It made sense to that in a very practical way. So they were very supportive, but it does help to be very proactive with that and upfront about it and say this is what we're doing. So it's a really good lesson in positive engagement with our patients. Yeah.
So it's a good patient education beforehand is
yes,
important. Yeah.
Absolutely.
Okay.
Yeah.
Any other questions? Not today. Hamish, thank you very much.
It's my pleasure. Thank you for having me.
We'll see you for the next talk. Thank you.
Thank you.